right, now I can record.
Let me begin with a word of prayer. I'll try to stop wasting your time. Heavenly Father, we thank you for this day. Again, I thank you for the students. Just ask you to bless our work, help us to glorify you in what we do. And it's great that the students would just ask good questions as they have them, Lord. In your name I pray. Amen. All right, so up to this point, we have solved equations, but they've all been what? They've all been linear equations, right? One linear equation, or two linear equations, or three linear equations, right? And those are fine and fun and wonderful. But there's more, right? There's also something called a quadratic equation. What's a quadratic equation? What's a quadratic equation? Yeah, an equation with an exponent of 2. So ax squared plus bx plus c equals to 0, where a, b, c are real numbers with a not equals to 0. That, for us, defines what a quadratic equation is, right? We'd like to talk about how to solve these, okay? So I'm going to start out with the simplest, easiest way to solve these. We're going to start there, okay? So example 1, how about this? What if we're up against x squared minus 3x equals to 0? Can we solve this quadratic equation? What should we do? Any ideas?
Factor out the x.
Factor out the x is a great idea. So that's x, and x minus 3 equals to 0. You guys remember factoring.
Set both equal to 0.
It's back. What's that?
Set both equal to 0.
Set both equal to 0, right. So the principle, the logical principle you're using is if you have a product of two things equal to 0, one of them or the other of them must be 0, or they both could be 0, right? So set them equals 0, so that gives us either x equals to 0, which is well done, or we can have x minus 3 equals to 0, right? So what are my solutions?
X equals 0 and x equals 3.
And x equals to 3. Notice that the solution is 3, even though there's a minus 3 in the factoring, right? There's this mirroring, flipping of signs when we look at the factoring number versus the actual solution, right? They're not the same sign. So watch out for that. Well, that wasn't bad, right? Let's do one that's a little bit trickier. How about x squared minus 4x minus 5 equals to 0. Now this time, we can't just factor the x out, right? We actually have to think about the factoring. So what I do, and somebody asked me, well, can you tell me how to factor in general? And I'm like, well, not exactly. How do you factor? Well, you guess, right? You guess how it breaks up, and then how do you know you're right?
You find a multiple. What is the word for -5 that adds up to -4?
Oh yeah, so I put an x here, I put an x here. I'm trying to fill in these blanks, right? And I'm trying to find numbers who what? Multiply to give what?
-5.
Oh yeah.
Minus 5, and they sum to -4, right? They add to -4. So what should I put in all the blanks here? -5 and +1. Now that's what you say, but how do we know that you guys are right? What do we do? Multiply it out, right? Remember, factoring is just unmultiplying. So to check factoring, you multiply. Multiplying this out, I get back x times x, which is x squared. I get minus 5 times x, which is minus 5x, plus x, right? FOIL, first in or out or last, right? So when we FOIL this out, we get a minus 5, we get plus x, that gives us minus 4x, minus 5 times 1, minus 5. Yay, checks, right? Are we good? Now, does that solve the problem?
No.
Almost. What are the solutions then?
X equals 5 and x equals -4.
Yeah, so we have x minus 5 equals to 0, or x plus 1 equals to 0, which gives me just what you guys just said, right? X equals to 5, or what? X equals to negative 1. And do we really need to write out the thing that's right above those? I don't think so. Once you understand what's going on, like you can go straight from the factored form to the answer, right? If I have factored the polynomial, you can read the answer right off the factored form for where it's 0. Yeah? Now it's important that the factoring has to be set equal to 0. If I have factoring equal to 1 or something, it doesn't work. Because I don't know that the product of two numbers that's set equal to 1 makes either one of them anything particularly nice, right? Can you think of numbers that you can take the product of and get 1? How about 2 1/2? How about 3 1/3? How about 10 and a 10? Right? There's infinitely many pairs of numbers that you can multiply and get 1. But there's only one real number that you can multiply by another real number and get 0. 0 has to be here. Or it can be either place, right? So anyway. It's important that we factor things set equal to 0, just something to remember. All right, well that wasn't too bad. Let's look at another example. What if I have x squared equals to, let's say, 25? How should I solve that?
Do you have to like
Do I have the camera what?
set up in the right direction?
Well, we'll find out. Oh, we're good.
Isn't that 5?
Yeah. What, you said 5?
Yeah.
How did you get it?
Because 5 times 5 is 25.
5 times 5 is 25. Oh, you guessed.
No,
I
I
mean-
have my tables memorized.
Oh, you have the, but you know 5 times 5 is 25.
Yeah.
So my point is, you didn't use an algebraic technique. You just used like your arithmetic knowledge that 5 times 5 is 25, so it works in this pattern, right?
No, because it has a 2 on top, and if the x is, so 5 times the 2 power is 5 times 5, so 5 times 5 is 25.
Oh, I don't disagree, but my point to you is what you're doing is guessing.
I guess?
You didn't.
So we agree.
Yes?
No.
Kinda, she
Kinda.
forgot to square both sides.
My question is, what's the method? How do we solve
Square
this?
root, yeah, that one.
You would square root?
Like, what if instead of 25, I had, x squared equals to 17? What would you do then?
Square both
Square
sides.
root. Square root
Square both
17.
sides. Squaring would just make it worse. If I
Square root both sides.
Oh, square root both sides.
Sorry,
All right, now we got something. I'm not disagreeing with you. I'm just my point to you is like, it's a simple enough number. You knew that x 5 times 5 is 25. That's how you solved it, right?
Yeah.
What works there, right? Well, if we take the square root of both sides, what is the square root of x squared? You guys say x. I say it's absolute value of x. Remember, the square root of x squared is the absolute value of x. This is important because if you just put x, you only have half the story. See, the full story here is that this is meaning x is equal to, plus or minus x, let's say, is equal to 5, right? So what are my solutions? Plus or minus 5. There are two solutions. Same principle, but I can't simplify it because it's like it's a number. This is plus or minus a 17. This gives us a solution. X is plus or minus the square root of 17. Of course, square root of 17 is square root of 17. Whatever it is, it is. It's like 4.2-ish. I'd have to get a calculator to tell you exactly, Not really the point. Like the answer as it's underlined right there is a perfectly fine answer. It's an exact form. The decimal form of the square root of 17 is, I was wrong, 4.123. All right, so I was wrong, that's about 0.1 off. 4.123 is approximately what that is. So how could we have seen this with factoring? Let's think about that for a second.
You could have moved the 25 over to the other side and set it equal to 0.
Okay, and then what? This is,
Then it's just the x minus 5 and x plus 5.
right? Very good, yeah, and so that gives us either x equals to 5 or x equals to minus 5 as our solutions. So which is a better way of solving this, using the square root or factoring? I mean, that's a kind of a loaded question, it doesn't really have meaning. They're both legitimate methods.
Well, if you're teaching us factoring, then I'm pretty sure you want us to use the factoring method.
Oh, no, I'm not, my goal here is not to teach you factoring necessarily, I mean, that's part of our goal, but my goal today is really just to solve quadratic equations. So factoring is just a means to an end, but we are gonna learn some factoring, so. I'm not really disagreeing with it. Now, there's a pattern here let me just stop and appreciate a pattern. So here's a pattern, this is called difference of squares, something we should learn and remember. This is a pattern we can use for that factoring. I see your point. A squared minus b squared equals to a plus b times a minus b. This is something we ought to memorize, look out for. Anytime you have a difference of squares like that, you can use that factoring. All right. The other thing I should tell you before we go on. Let me accept my fate here. Let me give you a different example. So example 4, we could have something like 3x plus 2 quantity squared minus 16 equals to 0. If I ran up against something like that, I could use the difference of squares idea. Oh, you know what? This one's still. Let me make it uglier. Make it uglier still. Let's suppose you have, x plus 1 squared equals 0 like that. So if I had something like this, I can use the difference of squares pattern to factor this. I can think of this as being A, and I can think of this as being B, and see, I can write down, well, this is really, A plus B times A minus B, which in this case works out to what? 3x plus 2 plus x plus 1 times 3x plus 2 minus parentheses x plus 1. Parentheses are your friends. Don't let down your friends. And of course that's equal to 0, right? Because this is a squared minus b squared. This is literally a squared minus b squared above. So then what? Well, collect like terms, and then you can see what the solution is. I don't know yet. I can't tell yet from what I've written what the solution is. I need to do one more step, right? So like, simplify this, what do you got? 4x plus 3, and over here, 3 minus x is 2x, 2 minus 1 is 1, plus 1, yeah. Now, here, I would urge you to write down the step that I said you could skip in like example. We skipped that step in example 3, part B, right? We didn't write down the middle step. Here, I think it's in your best interest to write down, okay, so either 4x plus 3 is equal to 0, or 2x plus 1 is equal to 0, okay? Because then we can go through the steps. So 4x equals to minus 3, 2x is equal to minus 1, lo and behold, x is either minus 3/4 or x is equal to minus 1/2. Them's your solutions.
Are you allowed to have fractions?
Oh yeah, we can have fractions. We can have worse. So let me talk about the worse. So we have a theorem, and our theorem is simply this. If we've got stuff squared equals the number, then that gives me the solution, stuff equals to plus or minus the square root of the number. And this is a general theorem for us. It works whether the number is positive, whether the number is 0, whether the number is negative. Even if the number is negative, it still makes sense. It's just then our solution is what's called a complex number. So let me show you examples of this. So for example, if I have like x plus 3 squared equals to 7, right? relatively simple to start with, just 7. You can use the square root principle, right? We use the square root principle. And when we do that, what do we get?
X plus 3 equals plus or minus the square root of 7.
Yeah. X plus 3 equals to plus or minus the square root of 7. And then, as usual, solve for x, right? And there you have it. X is equal to minus 3 plus or minus the square root of 7. Those are your answers. Now, last class asked me, do I have to write with plus or minus, or can I write it as 2 different numbers? The answer is yes, you can go either way. This is a notation for both numbers at once. All right? When I write plus minus, you're allowing for both cases. Any questions about this? So, if we have a quadratic formula where we already have a square sitting there equal to a number, these are really easy to solve because we just use the square root principle, this theorem I just wrote. So nice, right? These are not, even easier than the factoring problem, really, right? But they don't have to, so like this is worse than a fraction, right? No, square root of 7 is not worse than a fraction? I think it's worse. Maybe this is worse, even more worse. Even more worse? X minus 1 squared equals to, let's say, minus 4. Can you solve that? Well, we can. We use the square root principle. And this gives...
I?
yes, we'll have the I in a second. I minus 1, X, you can understand I. X minus 1 is equal to plus or minus the square root of minus 4. Now, the square root of minus 4 is not a real number, right? This is something new, perhaps, for you. This is an imaginary number. The way we write square root of minus 4, let me just put it up here. So like the square root of minus 4, think of this as the square root of minus 1 times the square root of 4, actually. Now, the square root of minus 1 is what we call I, and the square root of 4, well, that's 2. So what we have here is x minus 1 equals to plus or minus 2 times I. I is simply a notation for the square root of minus 1. It's pretty old. Like Euler invented this notation in 1777, if my memory serves me correctly. So it's been around a bit. And if you look at books that are old enough, instead of having I, they've got square root of minus 1, 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 just written all over the place. It's horrible. I is so much nicer. And then what? X. Yeah, x is equal to 1 plus or minus 2i. And there's your solution. Now this is known as a complex solution. A complex solution, that's a complex number. A complex number has a real and an imaginary part, right? If the instructions for example 6 were find real solutions, if possible, to this quadratic equation, you should tell me there's no solution possible, right? Why is that? It's pretty simple. You can't have the square of a real number equal to a negative quantity, right? That's impossible with the real number system. If you have an equation like this, the answer necessarily is complex, right? It's an imaginary number. Now, imaginary numbers, that's an unfortunate term. Like, imaginary numbers are no more imaginary than real numbers. Honestly, they're well-defined and they can be constructed with, well thought out mathematical principles. We've had explicit constructions of complex numbers since like early 1800s at least. And if you want to watch a really interesting history of the complex numbers, if you watch that video I linked, it's about 20 minutes long. It's from a YouTuber, I think Veritassian or something like that. It's very interesting. He explains like the origin of the complex numbers as they typically appear in algebra, and also just a lot more about how mathematicians have like dealt with quadratic and then even cubic equations and their links to geometry, right? In particular, in that video, he explains why completing the square, this technique of completing the square actually relates to a specific geometric process of like of taking a picture and making it into a square. It's pretty neat. It's like in minutes like 3 to 5 of the video. Now, I don't test on the video, obviously, but I just think it's interesting if you want to watch it. So if you don't, that's fine. That's also fine. Okay, so moving on here. Anytime we have a square equal to a number, we're good, right? We use the theorem, plus or minus the square root, simplify it, we got it. Not bad, right? If you can factor it, well also, hooray, we factored, we found the solutions, we're good, right? So these are two basic competing elementary methods for solving a quadratic equation. Let's try our fortunes on another one here. I believe in fortunes. Let's test our might. So I'll let you guys try to factor this while I'm adjusting the camera. Example 7. You guys see if you can factor x squared plus 8x minus 13 equals. See if you can solve that by factoring. I'm pulling a prank on you. I want you to come to terms with the fact that you can't factor that. Try.
Factor what?
Yeah, you cannot factor that. Can you factor it?
How are we supposed to add up to 8x?
You have to use the quadratic formula here.
Oh, no.
I used to do that.
No bueno.
In fact, I did not learn completing this square until differential equations, but that was me being stupid. Because, in fact, completing the square is it is easier than the quadratic formula. And if you learn completing the square, it is better than the quadratic formula. It's like more arithmetically forgiving than the quadratic formula. I've seen a lot of students try to use the quadratic formula in college algebra. And I would say there's about an 80% failure rate in using the formula. Something like that. There's very few students who actually can successfully achieve putting numbers into that formula, putting it into a calculator, and getting results that are consistently, reliably good. So yes, the quadratic formula will solve everything, that's true, but it's also really hard to actually put into practice. So anyway, we'll come back to the quadratic formula, just not today, okay? How do you complete the square? So let me give you the algorithm and then I'll do it here first, okay? So here's the algorithm. Anytime you have something, let me put the algorithm somewhere like, I'll put it here. Okay, so if I have x squared minus bx plus c, let's say, equals to 0, the completing the square step is simply this. I take half of what's b, I just do like this. I'm sorry, I'm an idiot. There's a plus here, dummy. Me, not you. So I take half of the coefficient of x, I square this thing, all right? I write that. To be fair, when I do that, I have to subtract b over 2 quantity squared, and then I add c. So this step that I just made right here, so this, if you multiply this out, what you get is x squared plus bx plus b over 2 quantity squared. That's what this is equal to. So it's just an algebra identity that if you group b over 2 with the x and you add them, you square that. As long as you subtract the b over 2 squared next, you have not changed the expression. These are identical. This is an identity. And this step right here, going from here to here, this is what I mean when I say complete the square. That's it. It's just that step. That's all you need to learn, completing the square. Master that step, understand it, you can complete the square. That's it. To start with. Now, we can do more things with that, but that itself is what I mean by complete the square. That is it. Can you do that? I think we can all do that. Can you do it here?
What happened to the C?
The C is still there. It just rides along.
Where is it?
Right there.
It's right here.
I think he's talking about where is it in the red?
The red is
Like
just the
x
stuff
squared
that's
plus bx.
whatever's in the
It's not in there.
parentheses. Yeah.
It's not in there. This has nothing to do with C. It's completely governed by what's next to B. That is part of what you need to learn. So here, putting that into practice here, watch this. What is half of 8?
4.
4. So I do x plus 4 squared. I must then subtract the square of what I added.
Okay.
So I subtract 16. The 13 rides along, nothing happens to that. That's it. This is completing the square. It makes the x term go away, and it just leaves you with a square. This is the magic. What if b is an odd number? Then you get a fraction. Yeah. I'm trying to make it seem easier than it is today. That's my goal. So, yes, admittedly, there will be fractions. Admittedly, at some point, we'll have a coefficient in front of a, and that will cramp our style as well. But let's do the easy thing first. I usually do the hard thing first, and I'm trying to reform my ways. So, don't drag me into the hard case, please. Does that make sense? I mean, do you understand what we did? If you multiply this out, if you FOIL this out, we get what? X squared plus 8x plus 16, right? Do I have a 16 up here? I do not. So to be fair, I subtract 16. With that, I have these two terms here are identically equal to that. I've just added and subtracted 16 effectively, which is 0. It doesn't change it. It's the same thing. All right, so then what? Well then we go.
Find like terms?
No. Do this. So this is x plus 4 squared equals to what?
X squared plus 16?
Well, yeah, but move these to the other side, right?
Positive 16.
Move these to the other side, we get what? 16 plus 13 is
29.
29.
Sorry.
Then we use the square root property. We solved it, right? So x plus 4 is equal to plus or minus the square root of 29. X is equal to minus 4 plus or minus the square root of 29. That's the answer. This is easier than using the quadratic formula. It may not be easier yet because you're just hearing it from me for the first time, but after you learn this and make this part of your being, no quadratic equation can stand against you. They will all fall at your sword. They will lie beneath you, dead, vanquished on the field of mathematical battle. Hundreds of them.
Now you can tell everyone they should be a
Blood
math
mist will
major?
surround you. What's it? Sorry, what?
Now you can tell everyone they should be a math major?
Oh, yes, of course, everyone should be a math major. I forgot about that. Thank you for bringing back my central point. Are you a math major?
No.
Why not?
Because.
It's a small major. You get to know your professors. You want to have a life.
I think I can
Math is life.
No.
Nope. Not in science.
If you had science, then you would.
Yeah.
That's crazy.
I mean, say math is the queen of all sciences. I say math is the king.
That's crazy. Go ahead.
All right. Finally, one last thing, and then I'll give you your quiz. I'd like you to understand why you couldn't factor this. Now, one of you said use the quadratic formula to factor it. That's not wrong. But you see this right here? This is the gateway to factoring it. See, because I can rewrite that as x plus 4 squared minus the square root of 29 squared equals to 0. This is 29. 29 is the square root of 29 squared. This is a stupid trick, but it's one you need to know about, right? 29 is the square root of 29 squared.
Okay.
This is magical because this is the difference of squares. This is a squared minus b squared. So I have it factored. X plus 4 plus the square root of 29, parentheses, x plus 4 minus the square root of 29 equal to 0. That is the factored form. So this thing I just did, I would call this factoring via completing the square. By the way, you can always do this. This is algorithmic. Sometimes students ask me for, hey, what's the algorithm for factoring? I can't tell you. It's guess and check. If you ask me, what's the algorithm for factoring via completing the square, I would tell you, you make the coefficient of x squared 1. You take half of this, divide by 2. You group it in the square, you subtract that. Then you use difference of squares, and you write it factor. That is an algorithm. You can always factor a quadratic like this. No guessing. It's an algorithm. So anyway, more on that some other day. I haven't done it justice yet today, but just in passing. You guys see why factoring it with guessing and checking was impossible, right?
Yeah.
Nobody's gonna guess, oh, I know, 4 plus root 29 and 4 minus root 29, those are the numbers that when I multiply them, they give me minus 13, and when I add them, they give me 8, obviously, they do, right? But no one would guess this, right? I mean, no one I know.
I wrote it down just in case.
Anyway, all right.